My name is Craig Nishizaki. I'm Senior Director of AT Development at Nvidia, working in the Silicon Operations Department. My team and I, we're responsible for rolling out the OptimalPlus solution across our global supply chain throughout Asia. We've enjoyed a great partnership with OptimalPlus over the past couple of years, utilizing the tool to improve our wafer sort yields. What I'll be talking to you about today is the next phase of our deployment with OptimalPlus, where we can leverage all of our test data to improve our manufacturing yields and also to improve our customer DPPM and RMA rate. During my 9 years at Nvidia, I've seen our products enable so many advances in computer graphics. At Nvidia, we love to see explosions in computer games. With glass shattering everywhere, buildings crumbling, fire and smoke filling the air, and all this happening based on the laws of physics. It's amazing how realistic these effects have gotten with our technologies, and at Nvidia, we feel that we will continue to make the imaginary appear real. Nvidia was started in 1993, and in 1999, we invented the GPU, the graphical processor unit. Today, our technology is being used not only for gaming, but also in industrial design, special effects for movies, medical research, and many other areas which rely on visual computing. Our company is now 20 years old and has over 8,000 employees with offices worldwide, and last year we generated about $4.3 billion in revenue. From our roots in visual computing, we've expanded into supercomputing, mobile computing, and now cloud computing. Today, Nvidia processors power superphones and tablets, supercomputers, and yes, even supercars. As a fabless semiconductor, our Silicon Operations Department manages the manufacturing and testing of the chips that are used in all of these diverse markets. We utilize many different subcons located in Taiwan and Hong Kong. We support a large number of diverse products and packages, and our product and test engineer groups are spread out across the world in Taiwan, India, the UK, and the United States. So one thing within this environment, a problem is starting to emerge. Our traditional yield solutions have become much less effective in improving yields and quality. First, test data is spread out all across multiple tools, and there's no one tool that can provide an entire solution. It then becomes difficult for everyone to access these tools globally and to become proficient on all of them. It's also tedious to combine and analyze data from different operations. We utilize many different scripts throughout the company. And also, we don't have an easy way to use data from one operation to take action at another operation. For example, screening out a part because one parameter has shifted too much with temperature changes. This slide better illustrates the problem. The top row is our typical manufacturing test flow. So once the wafers come out of fab, they'll go to WAT, wafer acceptance test, CP, chip probe, or more commonly known as wafer sort. Then the die are assembled and put into packages, and they'll go to FT, or final test, and then to functional test. Functional test is done in the engineering phase of a product, and is typically removed for production. RMAs are custom returns. These aren't part of the manufacturing test flow, but they give us critical feedback on the product's quality. The middle row shows the different tools that we use to store and analyze data. And this is a combination of both internal as well as commercially available tools. And you can see that the data from the different operations can flow into one or into many different tools depending on the usage. The bottom row shows how we utilize the data, which ranges from yield monitoring and improvement, planning optimization, and financial reconciliation, and also customer return analysis. So just to summarize, that we see excessive delays in being able to analyze the parameters across all the operations. Also, it's difficult for the engineers to become proficient in all these tools. And again, it's difficult to be able to take action with data from one step combined with data from another operation. Okay, so let's focus on the optimal tests used at Watt and CP. So looking back 2 years to our selection of OT, we had a clear set of objectives to accelerate yield learning. We needed faster access to our data, and that data needed to be complete. Before, we were waiting hours and sometimes days for the data to show up in the database, and sometimes it never would. We wanted to develop a best-known methods in yield analysis across all of our different product groups worldwide through a common set of easy-to-use tools. Finally, with a huge volume of data generated daily, we needed to have an automated system that would alert us to the onset of any yield excursions. The results with OT have been extremely good. We've seen an increase in wafer sort yields through early detection of problems and having more analysis capability immediately at our engineers' fingertips. Also, we're seeing more common yield improvement practices across the group using OT. And this is through such things as a common set of reports showing the bin and parametric trends, as well as the usage of OT alerts. For example, one of our engineers set an alert, found a problem that was caused by a manufacturing misoperation, and could see the data affected by that problem. He then set up an alert to catch the problem, and we use that alert now on all of our products so that we can catch this manufacturing misoperation much earlier. This is just a snapshot of some of the information that we started capturing with OT. We were closely monitoring our watt parameters and looking to see and checking how they affect the different yields or the different bins, failing bins and good bins. We could also easily see the effects on test hardware, like probe cards, and how they would affect yield. So what we're seeing in this graph on the right, you'll see the yield for the different dual-site probe cards. And then going into it further, you can see that we've separated the yield by site for this dual-site probe card. So we now get this information in minutes rather than hours or days. And our success rate in containing and fixing the problem has become significantly better. Before OT, we wouldn't discover problems like probe card sensitivity until well after the wafer had already been sent to assembly, already diced up and put into packages, and at that point, it's too late. You've already lost those die, and you've already lost the dollars associated with it. So based on our initial success using optimal tests, we made a decision this year to consolidate all of our test data under optimal tests, expanding our usage now to final test, functional test, and RMA data. The reason behind this decision was to support our goal for end-to-end analysis of all of our test data. We also wanted to improve the time it takes to access data and to improve the quality of the data. We now have a unified source for all of our operations manufacturing test data, and this allows us to take advantage of cross-operational analysis to make better data-driven decisions to improve yields and quality. So here's how we're able to take advantage of the consolidation to OT. We can make better decisions in how we set our power and performance limits for our different SKUs by simulating the yield impact of these limit changes. And this will help us greatly improve our prime SKU yields with less unwanted inventory. And that means more revenue dollars and less waste created. We're also using OT to improve our customer quality. By putting RMA data into the same database, we can correlate customer failures to any combination of parameters at any combination of test steps or test operations. A customer failure may correlate to a certain location on a wafer or a certain AT parameter like leakage. The other area we're leveraging optimal tests is to help us test for drift. So we now have an easy way to screen out a part if one of its parameters changes too much based on different temperature conditions or something like a burn-in stress. And we can do this now without having to program fuses. One of the really powerful capabilities of optimal tests is the ability to view cross-operational data. So what you're seeing behind me on the screen is an animation of a stacked wafer map of a fab lot as it goes through each of the different test operations in the manufacturing test flow. Yield engineers are used to seeing watt and CP in this format. It hasn't been common to see FT and functional test data viewed as a wafer map. So this opens up so many different possibilities for yield and quality improvement. So normalizing to a wafer view in your cross-operational analysis, you can see that failures correlate to things like wafer location, neighboring die yield, parametric data, and many other conditions. And you would do this by overlaying your RMA or your custom returns on each of the different wafer maps for each of the different test operations. Next, let's look at an example of how we're using OptimalTest's data feed forward capabilities to test for drift. Our automotive products have very stringent quality requirements, so we've implemented a test which can screen out parts if a parameter shifts or drifts too much after burn-in. So here's a quick summary of how the test works using OT's data feed forward capabilities. So first, we take the initial test measurement at final test, and we'll call this final test 1. That measurement, that data is then loaded into the OT database. The part's sent off to burn-in, and then it comes back to test for the second insertion. Let's call that final test 2. So then the tester and OT's server communicate, and the previous measurement from the first insertion is then loaded onto the tester. The tester now makes a new measurement of that parameter at this FT2 step. It compares it with the previous measurement, and it will determine pass-fail on the part based on how much that part has drifted for this parameter. This next slide will give you a better graphical picture of how this test works. Okay, so here's the tester running the first test, FT1. Once it records that measurement, it sends it to the OT server, and it sends it with the specific part that it made this measurement off of, along with the data into the OT database. So then part goes to burn-in, and it comes back for the second test, FT2. The tester requests the data, and OT sends that first measurement from FT1 for that parameter. And the tester then takes the measurement, the new measurement, and it compares the two measurements between FT2 and FT1. And if that drift is too large, it will record it as a fail. And all this is happening real-time data feed forward with no impact on test time. So at Nvidia, we feel that the OT tool is extremely powerful. But actually, what's more powerful than this tool is the outstanding support that we get from OptimalTest. They continue to collaborate with us to understand our needs and problems, and we work together to develop solutions now and into the future. We're pretty excited about some of these upcoming features. So with virtual tests, we'll be able to create our own custom parameters from existing ones and put them into the database. So instead of just having a average ISUM measurement from watt, you can have a median ISUM measurement also in the database. And you'll be able to create new ring oscillator parameters based on a calculation using a number of different standard set of ring oscillators that you're already taking. And then you take this new parameter, calculate it, and put that back into the database. So essentially, what virtual tests is doing is it's expanding your set of data in your database to allow you to, it will improve your correlation for yield analysis as well as for customer return analysis. Virtual tests will also allow you to create a gauge of the quality of the part using your custom algorithm based on parametric data, location on a wafer, the yield of neighboring die, whatever you want. And then you could put that numeric result back into the database. So now you have another tool, another set of valuable information that's extending your original set of data, and it's all back into the database, and you can correlate and do all your studies now with this enhanced set of tests. The example that I showed previously with the burn-in drift, that example was just the first application of the data feed forward capabilities. Once you analyze your customer returns and determine a way of catching them, you create a signature profile. For example, the die on the edge of the wafer in the upper right quadrant with a leakage measurement greater than 10 microns. You correlated a bunch of custom returns to this signature profile. With OptimalPlus escape prevention tool, you can now set up the rules which give you the ability to screen for this signature profile of the custom returns. You then feed this information forward to a bin switch a die from good to bad at a future step, and that way you can screen out a potential custom return. We'll have the capability to continue to improve the signature profile to catch new customer failures. So if you get a new set of custom returns, you'll be able to go back to the data sets in WAT, CP, FT functional tests, and you can then play around and see if you can improve that correlation and then enhance your signature profile. So you have a new signature, updated signature profile. So your rules deck will get updated, and then you'll be able to then catch these new customer return failures. So I think the next slide will better graphically explain the process. Okay, so this is the cycle for preventing future RMAs. So you get a number of custom returns. So you start here and you'll collect data on these failures. And you'll look at data across all your operations. And then you'll try to correlate those failures to both real and virtual tests. And then once you determine that you've got a correlation, you develop and establish the signature profile. Then the next step is you want to simulate that effectiveness. Basically, how effective was this signature profile in catching the customer returns? So if you caught a large amount of failures, then that's the signature profile you want to go forward with. But let's say you didn't get enough of the fallout of the customer failures, so you wanted to kind of go back in and improve this. So you'll go back up, improve your correlation. Again, you may expand the set of real and virtual tests that you're looking at. You'll improve your correlation, and then you'll update your signature profile with these enhancements. And then, again, test the effectiveness. And now if you've significantly improved the effectiveness and you want to go forward with that, you finalize the signature profile, you update the rules desk, and then you use escape prevention to now flag units that have this signature profile. And using data feed forward, you'll bin switch the good part so that you can fail it at a future test step. And then as you get more returns across the life of a product, you'll continue this cycle. You'll keep improving your signature profile. You'll keep catching parts that will then not get caught by the customer. So in conclusion, partnering with OptimalPlus is providing Nvidia with a unified source for all of our manufacturing test operation data. And it's supporting our goal for making real-time manufacturing decisions. And it's also enabling us to resolve manufacturing problems and catch errors much faster. And it's basically allowing us to continue to improve our yields and to improve the quality of the product. What we're most excited about is there's a lot more ideas that we're talking about. And we feel that we're only at the tip of the iceberg right now. And there's a lot more capabilities. And with our collaboration with OptimalPlus, we feel this just growing and growing. So thank you very much. And I'd like to open up discussion for any questions.
Could you talk for a little bit on what the challenges you had in bringing data in from subcons?
Sure. I won't go back to the slide if that's okay. So the difficulty with the test subcons, actually, we weren't the first ones to go to the subcons. So a lot of that groundwork was already laid. There was one subcon in Taiwan where we actually were the first one. I think at that time, this was 2.5 years ago, I think there was a concern by the subcon about not necessarily our data coming out, but the fact that are the other customers' data secure. So I think that's really, so that was really one of the key things that I found with OptimalPlus. They had this infrastructure, and it's an infrastructure that the subcons really grew to trust. And so we were able to use optimal tests to be able to get into our subcon and to where they didn't have any concerns. And we had tried with other tools that we had, and that was always a difficulty, trying to get through the firewall. And we never really had we didn't have a robust solution that was also fast. And so I think now it's, as we add different subcons and foundries, it's extremely easy right now. But the difficulty was more on the level of the trust of the data going through, because this was kind of a new thing that the customers were asking for of the subcons.
Yeah, my question has to do with the customer perceived DPPM reduction. A lot of times when customers send stuff back, there's no fault found, or they give you very little information. So I was just wondering, how fast was your cycle of learning to optimize this artificial intelligence, if you will, for the data forward? And how did you avoid excessive overkill?
Well, we're kind of right at the tip of the iceberg there. So the capabilities that I show at the end, those are features that are coming. Now, it'll be based on a lot of the practices that we're already using. And the difficulties are that, the communication with the customer, getting information, getting the right information that it's readily available to everyone, and then being able to then proceed and be successful with correlations. So we've done that manually. We've brought optimal tests into, and we presented this problem statement to them. And that's really where we got together with the data feed forward capabilities. So what you're seeing in terms of that whole cycle, it's just starting. So there's some new features that are going to enable the data feed forward capabilities. But we feel that because we've had to do it manually and we know that it takes a long time, we know that if we could speed it up and if we get the right data at our fingertips faster, we'll be much more successful in turning and correcting these problems.
Hello, my name is Stefan Wock from Infineon Technology. I have basically two questions. One was more or less already asked a little bit, and about your yield learning and these rules to avoid overreaction. Is there a simulation behind the system using all the old data to get, to avoid rejection of devices? This would be one question. And the other one is, how do you deal in your network with these demanding requirements to have the data available on the spot? You presented the tester is running, so to say, I achieve a test, and then the test needs previous information. How is this done in the network environment in your production area?
I'm Michael, I'm the CTO from Optimal Test. I'll answer that question directly. First of all, we've got simulation capabilities, and I'll demonstrate them in our demo shortly. So when you've created a new rule, just as you suggested, you can take that rule, you can then execute it on historical data to understand exactly what the fallout is, to what extent you're going to be over or under killing parts. And what was the second question, please?
The second question was the challenge on the network, how to get this data on the spot, or immediately. You're saying it has no test time impact. I would expect database access time or whatever.
Yeah, well, I can't go into too many technical details on that. We've actually been running that as a pilot at Nvidia, and we've shown it is 0 test time addition, except for actually the first touchdown. And what we're doing is some smart caching there. So when we bring the data for the first part, we're actually bringing data for other parts in that same lot. We already know, we can predict which are the next parts that are going to be under test. So by the time the part reaches the tester, we've already got the data for it. And it really is 0 test time impact.
In your FT reconciled wafer maps that you're showing, what type of metadata are you leveraging to make those? Is it fuse, or is it sorter.com, or how are you reconciling your FT wafer maps? What's the data that's used to do that?
John, do you understand the question?
Yeah, how are you doing the XY coordinates when you reconcile your wafer maps for at FT and QA levels?
Well, the XY coordinates are fed, they're basically in fuses. So at any test after assembly, then that fuse information is recorded in the log and is stored in the database. So FT will record the ESID. So we always know the XY and the fab lot and the wafer ID.
Okay, thank you.
Yeah.
Thanks. Bob Madger, Global Foundries. So a question was about feed forward for actual test program changes. So are you currently actually changing your test flow adaptively based on feed forward? And if you are if that's part of the iceberg that you're going to be doing next, and are you planning to change the structure of your test programs and your infrastructure to allow adaptive testing?
Right, well, let's use the first example in terms of the drift measurement. And so, yeah, there was a specific test method that had to be created to be able to do this, to be able to, as the data came in, the test method had to capture that, and then the new measurement, and then perform the delta. In terms of data feed forward capabilities in general, yeah, it would have to be something where using the rules alert, a signal would be sent forward so that before the next test would start it would check the OT database and see if there's any alerts. And if there's alerts, then it could be something like just automatically just failed apart. Once it's identified itself through its unique ID.
This is Yan Liang from Maxim. I just want to know, in the first slides, you showed that you have different tools at each stage, but later you switched all to the optimal test. Is it because the other tools cannot do it? Or is it because the other tools can also do it, but optimal test is better?
I think it's both. So we're not planning to abandon all the tools that we have. Those still have some specific use cases that the group does use. There are some tools that will consolidate, but the reason for having all in a different database then is it is much faster if everything's in the same database, and also the engineers that are using these tools, it's really, we find that it's really sped things up if they just get good on one set of tools or just one or two sets of tools. So it's sped up the capability of our engineers to be able to go and know where to find data and get it quicker. And it's also, we really are pushing the accuracy of the data, making sure that we're double checking each of the test operations. And there's some capabilities with an optimal test that ensure that at each test operation, that it got the data. I think one of the worst things for our engineers was when they would go in and query and try to find a certain parameter, it's not there. So I think the key thing in this whole infrastructure of the data flow is not only is to ensure that you're getting all the right data. And you may not know, right, unless you don't know exactly what was tested all the time. So if you're missing data, how do you do that? And so with some of the capabilities we put in for data checking, we make sure that we reference a golden set of lots that are being tested. And we always compare to make sure that we're getting the data from those lots. So I think it's kind of a combination of things. I think OT is also for us has been, the time to query has been much faster, and we're seeing that improvement as we brought in final tests and functional test data. We're seeing that improvements from the speed to access and get all the information.
Hi, I'm wondering how much extra stuff you have to add to a test program to implement this.
It really hasn't been that much. The example that we showed with the burn and drift, that required, that was a new test method. But really, I think the biggest change over 2 years ago, or 2.5 years ago, was we had to standardize our data formats from different products. And so, in terms of the test program style, we had to make sure that, the print statement was done, in a specific way. And so before we were kind of getting around that because we had all these custom scripts and we go to the logs and different engineers would do different things. And so I think also part of the reasons of going to one tool is now also to standardize and enforce the data format.
How long take you to set up your first product for optimal test?
How long did it take us to set up our first?
The cycle time if we want to implement the OT, so how long it take?
Okay, so just the implementation time. It was, I have to go back 2 years. So compared to other tools, I thought it was pretty good. We mentioned already the ability to get into the subcon. So that problem, or adding that subcon, was pretty quick. I would say, maybe 2-3 months type. And usually we were facing much longer delays than that. A lot of the other infrastructure, I think our IT department got very involved with OT's IT department, and so we ensured that the infrastructure, both what we had at Nvidia and also what was put at the subcons, made sure that all those data connections were set, they were fully tested out. So that went really quick. Once we had the servers there, obviously you do lots of testing and make sure, but I think from start to finish, we're talking maybe 4 months or something. I really can't remember too much. And now, as we're adding things, it goes very quick. We're bringing on subcons, I would say, in less than a month sometimes. New subcons.
I've seen OT, we use that for bin map analysis, we do some yield analysis, test time analysis, but I didn't really see anything with regards to the actual data, where you can, over a period of time, see trend charts, see how the data is in terms of process with time. Is that something that's coming up in the future?
Well, we showed an earlier chart about the watt trends and the bin trends, and then an example of the wafer sort yield based on probe cards.
Yeah, yes, we are using that, and I see a value in that, but in addition to that, can we have access to the actual data for the test?
You mean in terms of querying it out of the database and then taking it to other tools?
Or just analyze in the OT database?
Sure. I think one of the things that we definitely use are the integration with Jump. We use that a lot now, and so that makes it more seamless. Did you want to expand on that?
Yeah, we have many capabilities to show parametric trends over time based on parametric test results, and just about anything in the database you can put out and put in charts, or as Craig said, you can export it all to Jump as well. All of that's already supported in the tool.
Okay, is the database big enough to load all the parametric data over a period of time?
Yes, the database is, and I'll talk about that a lot in the demo shortly. Okay.
And we've been pushing it pretty hard. By adding the 3 additional test operations, so far, everything's been really good. And we've added in a number of parameters.
Were you able to integrate the OT on any of your in-house testers, or maybe doing characterization?
Functional tests, we consider an in-house tester. And so that was kind of we had to take a look at the log and then figure out what data we wanted to parse out of it and put into the OT database. But yeah, the functional tests, it's basically a system level test, so that's a custom tester.
From a practical standpoint, the test and the product engineers at Nvidia, do they still do their own ad hoc scripting, or is all the investigation and analysis work now done within the OptimalTest tool suite?
I think it's increasing as we add these different data sets, these different pieces of data from different operations. We're seeing the usage of OptimalTest go up, and so now I think we are seeing a trend where there's less custom scripts that people that had custom scripts or thought that they needed to analyze their data a specific way, they're now asking about OptimalTest because now we've enabled that set of data coming in. So again, it's one of those things that's growing, and as we add more features later this year, then I think the usage will continue to grow, and we'll start seeing a lot less custom scripts being done. But we are seeing a reduction right now. Okay, well, thank you very much, everyone.